Picture this. You are sitting dead center in the exam hall. You turn the page and boom, there it is, a seemingly straightforward past paper question on data transmission. You're probably thinking, oh, I've got this one in the bag. But actually, you are about to step right into one of the most common, literally mark-destroying traps in the entire syllabus.
Let's look at the exact scenario. The receiving computer calculates a check digit that does not match. So what does this show? Well, picking what feels like the most obvious, intuitive answer here is going to score you exactly 0 marks. No way around it. This is a classic brutal trap directly from a Cambridge past paper, and it catches thousands of students completely off guard every single year.
Let's look at the options they give you. The receiving computer has the wrong hardware. The signal has timed out. The transmitting computer has the wrong software. Or there has been an error in transmission. Now, here is the painful mistake so many learners make. They see two computers communicating, they see a mismatch, and they immediately treat it like a broken app on their phone, right? They jump straight to option 3, assuming the transmitting computer must just have the wrong software. It's a brilliant psychological trap set by the examiner.
Okay, let's dive into this. The common myth is blaming the software, but the fact? The software actually did its job perfectly. It generated and sent the data exactly as it was supposed to. The failure didn't happen inside the computer's programming, it happened out there in the wild network. The data was corrupted in transit, meaning the physical environment between the two computers is what actually broke down.
Section 1. The check digit mechanism. To truly master this, we really need to uncover what actually happens to your data as it moves from one machine to another. Let's look at the precise exam-safe definition. A check digit is an extra digit added to a code number, calculated mathematically from the digits themselves, used to detect errors in data transmission. Think of it as a unique digital fingerprint for the transmitted data. It absolutely does not care about what software made the data, it only cares whether the data arrived looking exactly the same as when it left.
Let's see how this builds across the whole transmission process. Step 1. The transmitter calculates that check digit using a specific mathematical algorithm. Step 2. The raw data, alongside that newly minted check digit, are sent across the network. Then, step 3, the receiving computer takes the data it just got, recalculates the check digit itself, and compares the two. If there is a mismatch at step 3, it proves the transmission is the culprit, not the software. The data broke while traveling.
In a moment, I'll show you the exact examiner clue that changes the answer completely. But first, you need the framework that makes that clue obvious. Without understanding the underlying nature of the data being sent, that clue is going to remain completely invisible to you in the exam hall.
Section 2. Hexadecimal and the nature of data.
Now, what's really interesting about this is how we actually map out the journey of different data types. Because as you know, everything inside a computer has to be binary, just ones and zeros. Text characters use the ASCII system. Digital graphics use a 24-bit bitmap system to store millions of tiny pixel color codes. Software instructions are converted into machine code for memory addresses and error messages. But staring at millions of ones and zeros, yeah, that's practically impossible for humans. So we represent this binary data using hexadecimal, creating nice, easy-to-read codes.
And this brilliantly illustrates why programmers absolutely rely on hexadecimal. It converts easily and directly into binary, sure, but it is vastly easier to read, write, and check. When things go wrong, like a transmission error causing a check digit to fail, the resulting error messages are almost always displayed in hex. It simplifies debugging massively. I mean, spotting a mistake in a short hex code is infinitely easier than finding one flipped bit in a massive wall of ones and zeros, right?
Before we apply our exam framework, we really need to clarify two crucial terms that get mixed up all the time. Validation checks if data is reasonable or fits certain criteria, and this is exactly what our check digit is doing. It's a powerful form of automated validation checking for transmission errors. Verification, on the other hand, just checks if data was accurately copied or entered by a human, like, say, typing a password twice. So the check digit mismatch we're looking at, that is a failed validation check.
Section 3. The high mark framework.
So the crucial point is knowing exactly how to translate all this theory into a bulletproof exam response. Notice the contrast here. The generic, flawed student assumption says the computers don't match, so the software is broken. It sounds kind of logical, but it completely ignores the scenario. The top band answer applies the correct technical vocabulary. It says the mismatched check digits indicate the data was corrupted, meaning there was an error in transmission. See the difference? This directly addresses the command words and the actual scientific reality of the problem.
Here is the foolproof 4-step framework that literally guarantees top marks on any data transmission question. Step 1, identify the concept, so in this case, the check digit validation. Step 2, state the evidence. The digits simply don't match. Step 3, provide the scientific reasoning. The data must have been corrupted in transit. And step 4, use the precise examiner wording to absolutely seal the deal.
Which brings us to the final missing piece of our curiosity loop from earlier. When you face this trap question, this exact, uncompromising phrase is what the mark scheme demands. There has been an error in transmission, not a software bug, not a hardware crash, just that. By following the framework, the track becomes utterly transparent, and you secure full marks without even breaking a sweat.
To make sure you never fall for another mark scheme trap, make sure to subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We're breaking down every hidden syllabus trap just like this one, so you can walk into that hall with total confidence.
But before we wrap up this explainer, I want you to think about this. We just solved what happens when the check digit flags an error. But what happens if the check digit perfectly matches, falsely validating the transmission, but the data is still completely disastrously wrong? This terrifying scenario actually happens due to something called data collisions, and it is a massive curveball. To find out exactly how to solve it and secure those next-level marks, you have to join me in our next explainer. Seriously, you do not want to miss it.